go ahead and get started. Anyway, we're looking at tanks. We're kind of going to look at, basically some stuff. Talking about fixed tanks. We're not talking about mobile DOT, mobile fuelers, that kind of thing. We'll go over some permits and inspection requirements. We'll go over a little bit about plan check, and I think we're kind of going to not go over a lot of the SPCC stuff, so we'll see as we go. Some of these slides I'm going to go over a little bit quickly. So anyway, the fire code we're talking about specifically, we're not talking about health and safety code, we're not talking about the ASME, and we're talking about what's in the fire code. And so basically it is incorporated in Title 24 of the California Code of Regulations. There's also a building code which references some of these standards. Anyway, Title 24, it is available online, I believe, and I know the fire code this year for the first time, I believe, is available online. Usually they make it available after they sell all the books, and we have a copy of the 2010 California Code. Just a little bit of background. For many years we were on the Uniform Code, Uniform Series in California, and up to 2001 we were Uniform Fire, Uniform Building, Plumbing, Mechanical, and such. And then 2003 or so we adopted the International Code. So these codes, the 2010 California Code is really the 209 International Fire Code we've adopted in California for 2010. Same with the mechanical codes, and all the rest of the codes are all based on the international codes. Anyway, we have, in addition to the fire code, some cities, some counties have local ordinances. I know we have in Orange County some sprinkler ordinances. We've added to the fire code and different kinds of things that are more specific, and any city can do that, any county can do that. So in addition to your fire code, which is based in California, it takes the international code, makes it into a California code with some amendments and adopting some things. And there's also local ordinances will make some changes on those as well. So you have to look in a couple of places when you're trying to find out. We have a few things in the fire code and building code, maybe call it alternate methods. That's not chapter 104, that's not chapter 10, that's chapter 1 in the fire code. They call it section 104. Practical difficulties. If you can't comply with the code, you're allowed a couple of these things. The alternate means and methods, we call it AM&M, to submit something that's as safe or safer, but not quite meeting the exact language in the fire code. There's a practical difficulties clause. That has to do with, say this particular picture is showing, a flammable or combustible liquid tank right next to a building. Well, what they probably did to avoid the setbacks and the distances, they probably built a 2-hour, 4-hour wall. It's supposed to extend 18 inches above the tank. So practical difficulties in AM&M, those are type of things you do when you can't quite meet the intent of the code, but you're providing a safe alternative. Also, for the first time in a while, we have really the risk management plan, the CalArt program is actually basically spelled out in 2701 as a performance-based design alternative. Nobody quite has said, I want to submit a CalArt on this process in lieu of complying with some of these things in the fire code, but performance-based design section, if you read that, that's the table of contents to the risk management plan and CalArt program. If you actually look at the 12 elements of the process safety PSM, it's in the fire code now. It has been for a cycle before the 2010. Some of the standards that are applicable by reference, they're in the fire code by reference. NFPA standards. NFPA 30 is the big one, flammable combustible liquids. We also reference ASME, which is your society mechanical, and your API petroleum and ANSI standards. We say the fire code takes precedence, but we do reference these other by reference. We have a section in the fire code under existing tanks, and they talk about maintenance and inspections, that kind of thing. They also talk about violations we can write under fire code. basically is a section called conflicts, and it's when something is, for example, you have a above ground tank could be for a cryogen, or it could be for a toxic, or it could be for any kind of hazmat. Hazardous materials is a general term, which is chapter 27 in the fire code. However, in chapter 34 is your flammable combustible liquids. So let's say you're getting into in chapter 35, I believe, is cryogens. Well, those more specific sections or chapters would be what you would be looking at for compliance, and usually those are more restrictive than the general tank stuff. So if you're talking about a petroleum tank, it's chapter 34. You're talking about cryogen, oxidizers, all the hazmats are listed in the fire code. Some of the definitions that we have are listed: stationary versus portable, above ground, protected tank. We're going to talk about that. Approved and listed tanks. We're going to talk a little more about that. Basically, classifications of hazard classifications of liquids. A lot of times it's based on flash point, which gets you into the combustible liquid or the flammable 1Bs. Gasoline's a 1B, diesel's a combustible liquid 2. So those definitions are basically a flash point and a boiling point. We're not talking about, in chapter 34, we're not talking about compressed, cryogenic gases. LPG has its own chapter. Liquid hydrogen is not is a compressed flammable gas. So there is an NFPA standard, I believe it's 52, just for alternate fuels for vehicles and things. So there's a lot of different chapters and things you can get into for special gases and liquids. Permits. What is a permit? Well, you could have a permit to install a tank. Plan review to the city, to the fire department. You could be issued an operational permit from the fire department. You could be asked to remove or close that tank, a permit to do that. So it doesn't matter if it's above ground or below ground. Above ground tanks, same thing. Installation, operation, closure. A lot of times I'm taking down, moving above ground tanks. Fire department doesn't hear about it, isn't really kind of in the loop. Underground tanks, usually the health department is saying we're closing this tank, and we'll go ahead and get a permit and inspect that closure. So permits are required. They're in this section in the fire code. We actually have a copy of the 2010 fire code here, but I'm not going to have time to kind of go through. But these operational construction permits, inspections, what inspections are required, conditional use permits, you've heard of that. Abatement, stop work order, those are all specifically referenced in the fire code. You can read those if you come across something in your particular project. Construction permits are usually to construct. Sometimes you'll see a permit that says to construct and operate, but the fire code will write you a operational permit on a tank, and they may even write you a chemical permit, a flammable combustible liquids permit, instead of writing a tank permit. And then to alter, remove, abandon, that's also under the permit section. Terms, basically an installation permit, usually the time frame is 180 days, which is 6 months. You can get those extended. That same 180 days is applicable to a lot of different permits. You can see the building department, building a house or a room addition or whatever. They always have that 180 days, and then you renew it. Some of the things that we're going to inspect, alarms, level controls, and such. We're going to have NFPA 30 as part of your review of plans that come in, and then when we go out and do the final inspection, we'll look for different appurtenances that were added to the tank, piping, relief valves, and such. The B31.9 is a piping spec. You've probably heard of B31.1, 2, 3, 4, or whatever. Some of the different B31, those are ANSI standards, or ASME standards, I should say. Power piping, steam piping is B31.1. I wrote a couple of these down. Process piping has another number. Refrigeration piping has another B31, whatever. So specific piping specs, which talks about the piping materials, the welding requirements, the X-ray or however you're testing the welds, hydro test limits. Generally speaking, hydro test is 150% of the maximum working pressure. So if this pipe is supposed to run at whatever, 100 pounds, then 150 is 1.5 times that. Doesn't mean that's all the pipe can handle, but that's all the hydro has to be. So a pipe could be good for 1,000 psi, but yet the hydro only has to be 150% or 1.5 times what the actual working pressure is. When we do pressure checks, we usually look that pressure hasn't dropped in 10 minutes. A lot of times you'll see a lot longer period where you're coming back the next day or you're coming back later on, but at least 10 minutes without deterioration. Operational permits. Again, we talked a little bit about installation permits, operational permits, and removal or closure permits. So an operational permit doesn't really have an expiration date on it. When you issue a permit for months, it usually doesn't have, it may have a date when it was issued, but probably does not have an expiration date. So it's good, but it requires a certain amount of inspection. Maybe we'll look at it every year, maybe we won't. But it needs to be maintained by the owner or operator. So your permit basically is good until we take it away or you don't need it any longer. That picture on the top is a very typical arrangement for even for a high-rise building where you have a generator, diesel generator in the basement. Right here, it has a day tank also in the basement, and this is your above-ground fuel tank sitting above it, sometimes at different elevations. So very typical arrangement. We actually had a high-rise building with an incident last year where this thing runs on a timer once every Sunday or whatever it is, and so it does use fuel. This tank said, okay, I'm empty, open up this solenoid valve, turn this pump on, and then the level switch was broken here, and this thing almost drained the whole tank, almost pumped the whole tank into the basement. So we had a foot of fuel, diesel fuel, combustible liquid too. Not as bad as flammable liquid, gasoline and stuff, which is a lot more flammable. There's electrical panels in this room, there's all kinds of stuff. So a very common arrangement for high-rise buildings to have this tank sitting above grade. And that whole tank was at risk to it happening. So diesel kind of smells, so somebody caught it, and no fire. We went in there and found out that they weren't maintaining the level switches. They'd never been taken out and cleaned, and that's why this thing kept calling for more fuel when it didn't need it. This is your kind of a fueling station. This is your tank in the background. This might be even typical of a fire station who has fueling for their vehicles. Crash protection, spill kit sitting out front. Anyway, those are some. I got some more pictures of some examples. Planning. That's usually the city, county planning department tells you about. We want to have a fence around it. We want to have a decorative wall. We want to have whatever. They're so great to look at. So a lot of cities, when they get involved with big tanks, a lot of times ask for you kind of keep it covered up. It's not a security thing, although you might think maybe it is. Nobody knows there's a large tank there. But the city has a lot to do with approval of your location, and we have a lot to do with setbacks and no smoking distances and ignition sources. So the planning department usually comes first and says, yeah, that's okay with us, just put a wall around it or keep it away from the school next door or whatever it is. Anyway, generally the planning department or cities, and they don't care about indoor stuff all that much, just how it looks from the outside. And they will issue conditional use permit, and then you'll get go for regular. That means you can go ahead and start your design and whatever and planning, and then come back with your other design drawings and installation. And I'm not quite sure why we put this slide in here. I think we were going to talk about apparatus, so we're not really going to spend a lot of time on fire service features. But it's a separate chapter, chapter 5. Anyway, chapter 27, general hazmat chapter. Flammable liquid, diesel fuel, gasoline, those are hazardous materials. So hazmat chapter 27. You probably remember in the old days, it doesn't seem like that long ago, Article 80, Article 79, we used to talk about Are you Article 80 compliant, which is Haz Mat? Are you Article 79, which is Combustible, Flammable Liquids Code? So those chapters are all changed with the International Code. We have Chapter 27. So flammable, combustible liquids, those are Haz Mats. So the general provisions in the Haz Mat chapters apply. Signage, protection from vehicles, and all the general stuff that's in Chapter 27 applies to every Haz Mat. And there's a lot of specific chapters from 27 all the way up to 40, whatever it is. Half of that fire code is hazardous material chapters. We have some general stuff in 2701, HMMP, HMIS, hazardous material management plan, hazardous material inventory statement. Those are things that you kind of think of, well, we have hazmat disclosure. Well, the fire code lists hazmat management plan, the hazmat inventory statement as requirements. Usually we don't ask for a hazmat inventory statement, or we call it maybe a chemical inventory or chemical classification when a business first comes into business. We'll ask to see all that so we know that some of the general requirements are met. And then the hazmat business plan is your annual update, your 3-year inspection comes under hazmat disclosure, HMD or HMBP. Again, anyway, 27 is your general requirements for storage, maximum allowable quantities. You've heard of MAQs. We used to call them exempt amounts back in Article 79, Article 80 days. The MAQ, what's the maximum allowable quantity you can have in a ordinary type construction business? Is it sprinkler? Does it, you have the stuff in cabinets? Indoors or outdoors? So your MAQs are all Chapter 27. There's tables for that. Chapter 27 has your general requirements for design of containers. Talks about UL listing. It shows specific tank UL standards that are applicable to flammable liquids and combustible liquids. We're not talking about which class flammable, which class combustible. Just say generally these are some UL standards that we talked about. We have some pictures in here. These are really not double wall tanks. These are single wall UL 80 and 142. They're not typically used for, as fueling vehicles or fueling equipment. They're a storage tank. UL 142 single wall tanks that are diked that have secondary containment, or a double wall tank would also be in that category. And anyway, they're generally allowed for combustible and flammable liquids. Generally not for fueling of vehicles. We have what we call protected tanks. And that's because your vehicle itself is a source of ignition. And you're pumping in and out of a tank a lot. So that generally we have different requirements for that. UL 80 is primarily oil burning equipment, and it goes up to those sizes. The UL 2080 and 2085 are what we call protected tanks. If they're fire tested. Now UL doesn't test every single tank. They test this design once, and then they allow to put that label on every other tank. They don't subject your tank to this kind of temperature, but that's the test that design tank goes through at least once, and they're allowed to put that sticker on every tank that looks just like that. So that's not your tank that they're heating up to that temperature. It has to meet the standard, has to have the impact part of it, the ballistic impact of a 30 caliber rifle at 100 feet. I guess we can talk about gun bans and things at this point. Anyway, that's what has to be. You can't be able to shoot this thing from 100 feet away. So that's a pretty thick tank. Usually they're at least a 1/4 inch thick. That seems to be the minimum standard. Anyway, they actually subject a tank to this kind of heat. This is the tank over here, and this is something on fire. This is not a test. This is actually a real thing. And there's a lot of heat that comes off of these tanks, with these fires. Have you ever been to any kind of even a show where they're testing or burning something? There's a heat wave that hits you right away. That's the heat that these tanks have to be able to stand to this standard. I forgot what it was at Universal Studios. I was at some show, and when this thing burned up, that heat wave hit you that fast. And it was a lot of heat. I think it was water or something. But it was was surprised to see how much heat really comes off, something that's far away from you. Anyway, so basically what it is a tank with a tank outside of that, and fireproofing or in the middle here, and a double wall tank. So they add so many inches of thermal insulation. A lot of times it's a solid pearlite crystal solid. It's not like a blanket type insulation. It's more of a solid they use to get that kind of protection. A little more of a breakdown. So this is like a tank you would have to fuel your vehicles. It's a protected tank, so it's got the inner wall, it has some insulation, it has the outer wall, it has concrete. This standard has to meet that 2-hour fire rating, it has to have this concrete layer on in between the layers. It's reinforced concrete. This tank basically is it's almost like a bomb shelter in itself there, the way it's built. And they're more expensive. These are a lot more expensive tanks, but those are the kind that have less setbacks, property setbacks, property lines. You can put it next to your whatever. It has its own fire rate. So that AM and M we talked about, the practical difficulty of putting a tank next to a building. Well, this is a protected tank. It has a lot shorter setbacks, and I'll show you a picture. That's another one, kind of a flat-looking tank. This is a typical tank label that you'll see. Highland Tank built this tank. They built it to the STI, Steel Tank Institute Fire Guard. That's the standard. And then UL tested it. And they tested it for whatever flammable liquids. So this is the testing lab. Again, they don't test every tank, but they put this label, they tested a tank just like this. The builder, the listing, and then that's the reference standards. STI is like ASME, API standard. You know, again, the tanks usually have nameplates on them. They talk about basically just serial numbers, that kind of stuff. Island Tank, you can't read that at all, but that's the company. They built it. They're saying they built it to this fire guard standard. This is a trademark fire guard. UL 285, what we looked at for all the testing had to be done on it. 2-hour rated. That's the concrete gets that rated on the side. Chapter 27 also has, we talked about appurtenances to tanks. We have vents, we have level gauges, we have spark arresters, we have quite a bit, and all these things are listed in this chapter. And they have to be approved or listed for use. You don't put a spark arrestor on a ammonia tank, but you would put one on a LPG tank or a fuel tank. Some of the general piping, basically in this chapter you're not going to see where it says Schedule A pipe or whatever service and pressure temperature. You're going to see reference standards that just says material constructions are appropriate, labeling, shut off valve. So when you get into actually building something or checking to see if it was built to a code, this chapter is not going to tell you all the codes and standards that were used. It's going to say it has to be appropriate or listed. The fire code is getting more and more with language like that, so they don't have to repeat everything or change it so often. Again, chapter 27 is your general Haz Mat chapter, but we have flammable and combustible liquid, a more specific chapter. So the general requirements, signage, source of ignition, that kind of stuff, will be in chapter 27, but there may be something a lot more specific in chapter 34, depending on what kind of liquid it is. If it's a 1A, 1B, or get into the class 2 stuff. Chapter 34 also excludes some things. A boiler tank, it's a boiler for water. That's excluded. So there's some things that aren't in chapter 34 that are specifically spelled out. These are chapter 6 in the fire code is actually building services. So your refrigeration, your steam generating equipment, boilers and such are going to be in chapter 6 of the fire code. So again, these are not typically flammable combustible liquids, and they're referenced in another chapter. Again, that's not your average looking storage tank, that's a boiler of some kind. Anyway, chapter 6 has some of the standards that apply. I talked about different B31 codes for piping. They also talk about sprinkler requirements for cooling water application and for actually suppression water. So I don't want to spend too much time on fuel fired equipment tanks. We usually don't get into a lot of these. They're packaged boilers that come on skids. They're packaged diesel generators that come with an integral tank to them. They're even packaged fire water pumps. So the packaged stuff kind of the whole skid probably is listed or approved for service. So we usually don't get into a packaged unit and looking for design drawings on such. MAQ, maximum level quantity, and H occupancy. Well, what's an H occupancy? Well, it's different. You've heard of H3, H7, for hazmats or chemical corrosives and toxics. This is the requirements when you go above the maximum level quantity. If it says the maximum level quantity for corrosive liquids is 500 gallons indoors in a sprinkler building, and you've got 1,000 gallons, now you run into that building has to have some of the H occupancy requirements, emergency alarms, pull stations, secondary power possibly, emergency lighting and stuff. So when you go over the MAQ indoors, the H occupancies kick in. And MAQ raised from 120 to 240. Yeah, that was a while ago, but for your combustible and flammable liquids, we used to say 30, 60, 90, 30 gallons of a 1B and such. And then now they've raised it to 240. So take a look at your MAQ tables about the liquid you're talking about, and those requirements are there. Again, the table in chapter 27, the Haz Mat chapter, is where all your MAQs, the same exact table exists in the building code. It happens to be table 307. It's the same exact table, copied verbatim, put in the fire code. And we talked a little bit about fuel-fired equipment. Location, outside tanks, we're usually looking at setbacks, and we're talking about setbacks from property lines or property that can be built upon or other buildings on at your same business. So a setback is how many feet you can keep it away. Now, chapter 30 in NFPA also gives you similar setbacks. And we talk about property lines, public ways, or any place that could be built upon. If you're putting a tank in the back of your parking lot and it's an empty lot, well, that is not really an empty lot if it can be built upon. So someday somebody's going to put a school there or whatever. You've already got your tanker. So we have to look at, if your property line is on a slope and it just drops down, nobody's going to build on that. So we would allow a tank to be along that property line because the setback says property that can be built upon. So, or if you're up against whatever natural river, flood control channel, whatever, it's off your property, but it can't be built upon. So we'll look at that and allow you to put a tank next to the property line. Here's some of the setbacks. We're talking about outdoors. UL listing, we talked about the UL 142 was the lesser. This is the tank that's subjected to all the concrete insulation and all the robust construction features, and those setbacks are less because of that reason. So your larger tanks, we talk about 20 feet for an ordinary tank. Well, you can put that great big tank 10 feet next to a property line or any public receptor as long as it's built to this better standard. So that's where buying that really nice tank allows you to put it a lot closer because it's protected. You can't really catch on fire very easily at all. Weather protection, we kind of talk about, you usually run into this when you have a fuel tank and it's in the sun and it's vaporizing and your AQMB is permit says you can't have so many, you can't be venting a certain amount, so that we talk about certain square footage weather protection is required. We building code is chapter 4, and then fire code chapter 27 is where we find the setbacks. We talked a little bit about H occupancy, so we say H3 or H2 or H1 or H4. There's a different H for different hazard materials. Like if you're dealing with explosives, you're going to be an H2 type occupancy, and the requirements for H2s are there. If your Haz Mat, your MAQ is over on toxics, and it's a gas, we're going to require an H3 or an H7 requirement, which is going to have maybe a scrubber system outside for the chlorine. If that toxic is ammonia, we're going to require, ventilation systems that come on automatically. We require emergency alarms and pull stations and such. So, depending on what your hazmat is, your MAQ is exceeded, we're going to require certain things: secondary containment, ventilation, sprinkler, higher sprinkler density, emergency alarm, and those kind of things run into the when you get into H occupancy. You can actually have, I haven't seen very many of these, but I've seen fire pumps up high on high-rise buildings and on the roof and such. But generators also, you can, sometimes you see those in high-rises, and they're not always in the basement. But there's certain requirements that you're going to have to do. You're going to put that generator in a hospital, daycare, whatever, nursing home, then we're going to ask for special things to have that thing upstairs or indoors. A lot of times they're in the basements. You see them in the parking structures, for generators. These are emergency generators in case of a power outage. We talked. These are the MAQs actually on different floor levels. We never had this in the fire code before when we were in uniform code, but we now have MAQs that are on different floors. Well, on the first floor, let's say you're allowed to have 500 gallons of a corrosive liquid. I guess I should use a flammable or combustible liquid. But whatever, let's say your MAQ is 500. Well, you can have 500 on the first floor, but you're also allowed to have a certain percent of that on the next floor, which is a little bit odd because we don't like hazmats upstairs and way up high. In general, we rather have those down where we can, but you can't always, like I say, you may have that generator, diesel fire water pump, those are combustible liquid class 2s. Those have a certain size, and you can have certain a number of control areas per floor. On the first floor, we're allowed 4 control areas, and only a 1 hour fire resistant rating, which is the last column. These are hours, 2 hour firewall. You're going to have this tank on the up high over the 9th floor. That has to be in a room that's got a 2 hour rating and 1 hour rating. These are basements down here. Floor minus 1 is the first level basement, second floor, and then we don't have a lot of these, but there are some situations where it's built on elevation, and you actually have a first level that's actually below ground level. So those are requirements for MAQs. So you got to look at that when you're for new construction. You don't see a lot of, you don't find a lot of this stuff out on existing conforming, existing non-conforming. People call it existing illegal. There's a lot of stuff that was built to older codes. Anyway, generally the big chapter you're going to see a lot of this stuff. It is chapter 34, has its own definition, its own general requirements for storage, indoors and outdoors. There's a section for dispensing, use, and handling. This is for fuel stations, dispensing anywhere you're dispensing fuel. It's not just fuel. It could be acetone, or it could be hexane, or whatever it is that you're dispensing. This is flammable combustible liquid. It doesn't matter if it's fuel or gas or diesel. It could be hexane or benzene or whatever it is that you might be seeing in bulk. And we're talking about generally we're talking about tanks here, not drums. So big tanks over 60 gallons. That's why your 55-gallon drums don't really fit under this chapter. And your portable tanks, those are like those totes. You see the smaller ones are 275 gallons. The larger totes are 660 gallons. So those are all spelled out. Anyway, tank vehicles and tank cars shall not be used as storage tanks, so we're kinda saying those are, the things we're talking about are fixed tanks in general. We talked about NFPA 30, we talked about, chapter 27 is where you go. That's just a picture of a label, but it says the size of the tank. It probably says what it's, UL, it probably is a UL standard on this, it has serial number, size of the tank, and that kind of thing. So that's a kind of a corroded one. There's a typical diesel fuel tank for a generator or a fire water pump. A lot of times they're elevated. You have to have the bottom of this tank no lower than the fuel pump on the engine that you're talking about. So if you have a big diesel fire water pump over here with a big engine on it, its fuel pump has to be at least this level, otherwise you gotta raise this tank up. We find this a lot in older installations where that's so you can use the whole tank. It's rated for whatever, 500 gallons, that gives you 20 hours or 8 hours use. If it's not up high enough, you can't use this whole tank and you won't get the whole 8 hours or whatever. I've gone to places where it says, you're a foot short, you gotta raise it up. You know, a lot of it is flex lines and things. That's the way the code reads. So not, a lot of times things just go in, not for spec. Anyway, there's a lot of slides on tank vents, and I'm gonna go through those, and then we'll take a break. Tank vents, you know, you see all kinds of things on this tank. What the heck are all those things? What's a really tall one on here? Well, some tanks and spark arresters are raised up. Maybe it's because of the building next door, maybe it's because of the property line. And then there's other tank gauges and such on top of that tank. Normally, tank vents are 12 feet above grade. So maybe in that last picture, the tank was 6 and the pipe was 6, so that gets you to 12 feet. We don't want tank vents to vent into an unsafe location, a platform on another tank or piece of equipment, or a building intake ventilation system. So those kind of things we look at. 5 feet from building opening, you know, including non-openable windows. Okay, well, I guess that's the way it's written. These are typical tank vents that you'll see. They also have what's called a vacuum breaker, and they have flame arrestor requirements for depending on what the material in the tank is. Flame arrestor is a device. A lot of times this just has a steel mesh in it that would prevent any flame or embers from entering this thing, because it's a vent, right? So it's venting, so it'll stop. You'll see the same mesh on chimneys, fireplaces, that kind of thing. I know in the wildland areas and the work we're doing with defensible space and preventing all these wildfires, is we're looking at flame arresters, which is just some kind of a wire mesh or sheet metal, a certain size opening that protects from things getting into it. That's a flame arrestor for a 36-inch pipe. So anyway, they're not just a little cavity, it's some kind of device. You can look at any of these three are typical. What you'll see, they don't say flame arrestor on them. It doesn't jump. They aren't painted red, but they're required for the NFPA and Chapter 34 stuff. Their size based on what we call a fire case, is that vent has to be big enough to vent in the case of a fire, fully involved fire, without exploding or flooding or boiling it. So the vents, sometimes there's primary, secondary, and they're designed for a fire case. So,
excuse me, can you maybe restate for the camera that the emergency vent doesn't need to be 12 foot above grade? We've got an issue currently trying to permit a tank, and the fire inspector insists that the 12 foot above grade applies to emergency vents.
Yeah, we usually have normal vents and emergency vents. So you'll see on a diesel generator tank indoors, you'll see one vent going up and out the room and up, and you'll see another vent that's right in here. So we have a normal vent and an emergency vent. So it looks like
this is an outdoor tank too.
Yeah, so anyway, the requirements are in the code for emergency vents and for normal vents.
And he says it's clear in the code that the emergency vents need to be 12 foot above grade. If you go back to the part on vents, he says that just says vents, 12 foot above grade. It doesn't say breather vents, it doesn't say it excludes emergency vents. So he's insisting that the emergency vent have a riser, which is a real, you know, a problem for the proper function of an emergency vent once you put extensions on it.
Yeah, I would have to go back and look at that section to see if we really typed it just like it is. But, the code is pretty clear, so you may just be, like I said, we normally don't have both vents going that way. Usually it's one vent. Maybe he has the wrong one going out, maybe the normal versus
This is a very experienced fire inspector and just insists.
yeah, okay, well, I mean, everybody's a little different, but I would, I'm not gonna, you know, if you wanna leave me some
We'll
information.
do an email or something separate.
Afterwards, that's fine. Okay, so what I wanna do is I wanna just get through with the vents here. These are just pictures of different, nameplates. That's a vent. It shows when it was, probably says when it was tested or what it was designed for as far as cubic feet per hour. Again, here's a, outdoor storage tank. Has some, platforms and handrails at the top. If there's stuff that you're always gonna be working on or checking gauges or whatever the requirement is to have some kind of a fixed ladder and a platform, if you're never gonna be up there, you don't have to have it. Okay, anyway, there's a lot on vents, and you guys can look it up or ask specific questions. And I wanna finish up here. These are just some more pictures. Sizing of vents. Any longer than a certain size requires engineering. Okay, so we're gonna stop at this point, and we're gonna take a 15-minute break. And then Victor's gonna finish up with the second half of the presentation.
Is it required